Welcome everyone, my name is Kirill, I'm software engineer and I'm really surprised that I didn't publish any new videos almost half a year and still I attracted few more subscribers. Thanks a lot for your trust. As you may have noticed, I have a new camera, so I hope you can feel the difference in the picture and I hope you like it more. And let's get started. Today is a very interesting topic. I will be talking about comparison between Terraform and CloudFormation. Oh, a versus battle. Terraform versus CloudFormation. I've been using Terraform in different companies for more than 3 years now. And I wrote some internal tooling. I wrote Terraform provider for a particular use case. So I'm very confident with this tool. With CloudFormation though, I have way more limited experience. I obviously learned it, I tried it at home, I used it in one company in production, in an existing code base, so I also saw some tooling around and I saw some problems that I faced and that people faced. Today I will do my best to be not biased and compare them in different use cases and tell you my verdict. So stay tuned, let's get started. I picked 12 different features, 12 different amenities we will be comparing them on. Here they are. They should pop up somewhere in the screen. At least that's my plan. I'll start with the simplest one, the language, the DSL that tool uses. Terraform is written in Go, however it uses its own DSL code called HCL, which stands for Hashicorp configuration language. And this is how it looks like. CloudFormation, on the other hand, uses JSON or YAML, whatever you choose. I personally feel JSON or even YAML way less readable than what Hashicorp offers us. However, I know plenty of people who say the opposite, who are mad at Hashicorp that they invented yet another language. Because yes, it is a different language and you need to spend some time learning it. Yeah, it's quite basic one. You will probably need a couple of hours at most to learn the language itself. It should be enough for you to use the tool. However, yeah, you need to at least get familiar with it. So I don't see a clear winner in this feature because they both have some language, they both has pros and cons, they both has their fans and people who dislike the tool, dislike the language it uses, and so on. So I don't give my kudos to any of them, so it's okay for both. I will be giving 1 or 3 scores for every feature, either kudos, or it's okay, or it's a real downvote. So for this thing, for both of them it's okay. I don't feel that JSON or YAML is something that I can give kudos to, especially considering the intrinsic functions, which we'll talk about later. And HCL, for my opinion, it's a better language. It's more suitable for configuration, but still it is a different language and it has its disadvantages. And while we're talking about languages, the second feature we'll be talking about is the richness of this language. The richness of JSON, the richness of YAML. I like it. How much is this thing a real programming language? This is what I want to cover here. Obviously, neither JSON nor YAML is a real programming language. No one will argue this. However, CloudFormation adds some particular template functions which will allow you to use features of a language, of a programming language in there. CloudFormation supports quite a good selection of things you can use. It supports string interpolations, joins, selects, and so on. HCL supports all this. However, it has one more feature which I wasn't able to find in CloudFormation and which I find to be quite a useful one. The feature is iterators. Like, you're able to create iterators. For example, you have a list of IP addresses you want to block. You define just one resource, which is web application firewall rule. And basically you need to create web application firewall rule for every of these resources. So in CloudFormation, you will need to define, let's say, 10 resources, one for every rule. And for Terraform, you just say that this resource, this web application firewall rule resource is an iterator, and it will iterate through this list and create 10 resources for you. However, in the code, you will still have just one resource defined, which I think is a very neat feature. It helps you to dry up your code a lot. Just to mention, yeah, web application firewall rule may be a slightly contrived example, but I hope you get the idea. However, I need to mention that these iterators are quite weird in their syntax. It gets better in the new version of Terraform. However, it's still, when you see it first time, you're getting WTF on your face. But then you learn it, you understand how it works, and it's all fine. Again, it's a new language. Another cool feature of Terraform here is support of external functions. So basically you can have any external bash script or binary or whatsoever, and you can just use the output of this thing in your Terraform resources, in your definition. So it can be, again, contrived example, because there are other ways to get this information. But for example, you have some bash script which gets your instance metadata, and in Terraform you can use this instance metadata while getting it from this script. Obviously you will not be doing this, you will be doing it in some other way, but here is the idea. I will say Terraform is a winner in this case. However, at the end they both do the job, and yeah, Terraform is slightly richer. However, it's not that a significant difference. I will still give kudos to both these tools. So moving on to the next one. This feature is usually mentioned as the most significant one, the one that people are usually aware about. It's cloud support. I bet that you can guess that AWS CloudFormation is a tool from AWS, and Hashicorp, Terraform from Hashicorp. Yeah, so obviously CloudFormation has support of AWS. And up until last year, the biggest advantage of Terraform was that it was cloud agnostic and CloudFormation wasn't. So with CloudFormation, you were able only to manage AWS, nothing else. And with Terraform, you can manage AWS, Google Cloud, Azure, and tons of other side cloudy things. So it's designed to be provider cloud agnostic, so you can manage PagerDuty, GitHub, Datadog all together in your Terraform code. However, recently CloudFormation announced that they now also support third-party resources, so you can also define many things using CloudFormation nowadays. However, still Terraform has been designed with this idea in the first place. So for this day, it has wider adoption for third-party tools. It has more providers, and I would say if you want to manage resources outside of AWS, perhaps Terraform is still a better choice. So for this feature, I give kudos to Terraform, but sorry, CloudFormation, only okay for you. It's a good job. It's good that you're moving towards this direction. I think there's still a long way to go, and I believe CloudFormation can be also absolutely cloud agnostic in maybe half a year or a year or so. You probably think that because CloudFormation is owned by AWS, it gets support for new resources instantly. Unfortunately, it's not always the case. AWS is a huge organization, and it's not that easy to coordinate all the changes that quick. It's a fourth feature which I want to discuss today, and again, I don't have a clear winner here, because usually CloudFormation gets support faster. However, Terraform is almost completely community driven. I mean, not the Terraform itself, the Terraform providers, for example, provider for AWS. And it's usually the case that support for new features is added almost as fast as for CloudFormation. I haven't seen precisely, but I read that it's also quite often that Terraform gets support even earlier than CloudFormation gets it. It's tempting to say that CloudFormation is a winner here and gets kudos. However, I saw how quick resources are added to Terraform, so I will give kudos to both. The fifth feature, the next feature, we already briefly covered before, and I will basically just recap what I said. It's support for external data. In CloudFormation, you have a concept of parameters. So you can reference one resource, like resources from one stack. That's the way CloudFormation calls this isolated pack of resources. You can reference resources from one stack in another stack. So it's perfectly possible, and that's what people are usually doing. I had some issues where you have cross-reference and it doesn't work, but like cross-referencing is anti-pattern, obviously, so you should not use it. However, for Terraform, as I already mentioned, you have a huge variety of what you can reference where. Obviously, you can reference one Terraform state. That's how you call it in Terraform. The concept is similar to stacks in CloudFormation, but like the mechanics is different. However, you can reference resources from one state in another state, and moreover, you can reference external data. You can reference, for example, resources from Kubernetes you can reference in AWS and vice versa. And resources and even things that you retrieved using some bash script, you can also reference it as a real thing in Terraform. So CloudFormation does a good job here, but I think Terraform does a perfect one. So kudos to Terraform, and okay for CloudFormation. The next one can be easily overlooked, but it's really fundamental one and it's really important. It's state management. Remote state management is obviously a feature that exists in both tools. However, it's implemented in completely different ways. For Terraform, you have a so-called state file, which is an awesome concept. I really love it. However, the way you store it remotely is slightly awkward. If you're familiar with Terraform, you already know it. If you're not, maybe it will be easier for you to Google, to search for it. I'll just briefly mention that before managing remote state, you need to create something where this state will exist. And you either do it without using Terraform, or you use Terraform for it. So there are multiple ways of doing it, but basically it creates you sort of a chicken and egg problem, because basically you need to have S3 bucket and DynamoDB table created for you, so you can manage you can manage your remote state. As I say, there are enough of ways to achieve this, to work around the issue. However, with CloudFormation, you just don't have this issue. It just works. You just create a stack, you apply it, voila. So for CloudFormation, it's a big kudos for being that easy to start with, for being that prepared for developers, and I will give okay for Terraform. It's not dislike, obviously, because it has remote state management, but it can be better. However, while we are on this feature, I want to tell you about one more thing that Terraform has, and I really love it. It's the way you can manipulate your state file, the way you can interact with it. So you can easily move resources from one state file to another state file. You can rename resources there without touching the actual cloud resources. If something got deleted somewhere, you can just remove it from the state file. You can easily import resources and so on. You can even just open it with your favorite text editor and edit it manually. Obviously, you should not do this unless you absolutely perfectly know what you're doing, but it's possible. I will not give any score for this, but I just suggest you to keep it in mind. It's a good thing for Terraform, but again, for CloudFormation, it's just easier. You don't think about it at all. And expanding on this topic, I briefly mentioned it, is the ability to import resources, and it's easy, kudos to both. They both support it. It works for both of them, so it's all fine. The next important feature is a possibility to preview your changes before actually applying them to the cloud. If I'm not mistaken, previously, maybe a year ago, maybe 2 years ago, CloudFormation didn't have this feature. So Terraform back then was a winner also by this feature. However, now they both support it. In both of them, you can first plan and apply later, or create a change set, how they call it in CloudFormation, and only then deploy this change set. So kudos to both, good job. I personally prefer the way Terraform displays it for you, but it's just a matter of taste, and it doesn't influence my score here. Okay, let's move on to a completely different part. Let's move on to the code organization. For those of you who come from a purely application development side, it may sound funny that people in infrastructure, they want to organize, they want to structure their code. Come on, what code do they have? What code do we have? But yeah, we do, and we want to organize it. And thankfully, both tools try to help us with this. Terraform supports so-called modules. It's just a shared piece of code, let's say, which you can define in one place and use in multiple. You can parameterize it with some input parameters. So basically, it encapsulates certain logic for you, and you just use the interface of it, if I can put it in these terms. Another powerful feature of Terraform is the ability to use multiple state files, which gives you clear separation of your boundaries, more clear boundaries between your either your business domains, either your applications, or the layers. Like, it depends the way you structure it. There is no silver bullet for it. CloudFormation also supports both these features, just slightly in different way. For states, or more precisely speaking, stack separation, it's done more or less in the same way. You may have for one AWS account different CloudFormation stacks. So you can also set boundaries between your application, I mean boundaries in terms of code. Speaking about code reuse, it's done, in my opinion, in a slightly awkward way. You cannot simply reuse code. Instead, you define substacks or nested stacks. I didn't use this feature myself, but by Googling, I discovered that many people actually have issues with this feature. When you have multiple layers of nested stacks, one of them fails, then it tries to roll back, and the whole pile gets stuck somewhere, and it just doesn't work in the result. I would say that obviously both tools implement these concepts. However, I strongly believe the way Terraform approaches it is way cleaner, way simpler. You reuse code. You don't reuse some bigger entities. You don't reuse a complete stack or something like that. So I give good okay for CloudFormation, and not that big, but a kudos to Terraform. The next important feature, I mean, it's really important, is the possibility to auto-roll back in case of failure. For example, you define a VPC with some subnets and EC2 machine somewhere there with some security groups. And along the way, your EC2 machine creation failed. What do you expect then? If you expect that everything will stay as it is, like, I mean, something get applied and it's all fine, what hasn't been applied is just not applied, then this is the way Terraform takes. So, for example, VPC will be created, subnets will be created, but the EC2 machine and security groups won't be. However, for CloudFormation, it's implemented in a more elegant way. In this case, if it's one stack and you're applying it, it's either, you can select the strategy, obviously, but one of the strategies, I think it's even default one, is the auto-rollback. So in this scenario, if your EC2 machine creation failed, your subnets, your VPC, your security groups will be also rolled back. So this is really awesome. So in this feature, it's absolutely clear. It's just no for Terraform, and it's kudos for CloudFormation. However, given my personal experience, for me, it almost never worked well in these scenarios. A few times I had a case when my stack needed to be automatically rolled back, and it always was getting stuck in the update rollback error state, and I had to wait for some timeout time for this thing to be unfrozen. So you cannot just manually change things and roll back or stop it or something. It just gets frozen. It is, at least that's what was happening to me. I also obviously searched for this issue. I see that many people are facing this. However, by talking to my friends who are using CloudFormation, they say that it's not that often. So I will not deduct any score for this, but it's just a thing for you to keep in mind. I won't keep it in suspense. The next feature is also only available for CloudFormation, and it's rolling update for some things, like for example, for auto-scaling group. Imagine you have some auto-scaling group on AWS and you have multiple EC2 machines there, and you want to migrate these machines to be a different type, smaller, bigger, doesn't matter. What you will do in Terraform, you will first add more machines to this auto-scaling group, or you'll create a new auto-scaling group, most likely, yeah, the second scenario, and then you will switch the traffic and then you will remove the old ones. However, for CloudFormation, there is a native way of achieving this. It's this rolling update thing. It creates the new ones first, it ensures that they are healthy, and then it removes the old ones. I didn't use this feature on my own, however, I read the documentation, I googled for issues with it, and it seems to be fine. It seems to be working, and I also saw that it has plenty of opportunities to configure this thing, so I can say I like this feature. You can even not just watch for health signal on some machine level, but you can have some signal from the application itself, which will tell that not only the instance but the application is healthy. So as I say, I didn't use this feature, but like from the documentation, from what I see, from what I read, it looks like a huge kudos for me. And obviously it's no for Terraform, because there's just no such thing exists there at all. However, as usual, just to mention, in case of if you're using Fargate, ECS, or Kubernetes, I suppose you don't need this feature at all, because you manage your instance deployment just in a different way. You just don't manage it using Terraform or CloudFormation, or you don't manage instance in Fargate, for example, at all. The last, but not least, feature of them both is drift detection. I cannot imagine how would we live without it, so it's really useful. Imagine the following scenario. You created a private S3 bucket using your favorite tool, doesn't matter Terraform or CloudFormation, but then someone just went there to AWS Management Console and made this bucket to be public. If you would not have drift detection, you will probably never notice it. But with drift detection, on the next apply, on the next run, you will just see that there is a diff, that something that exists out there does not match what you have in your code. So you will notice it. Again, in both tools, this feature implemented slightly differently, but they both have it, they both offer it, and I can just give big thumbs up for both of them. Good job. So let's now count the scores. What do we have? I suppose I will visualize it here somehow. Pam 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 pam. And the winner is... Okay, it's not that obvious. We have 9 kudoses for Terraform, 2 OKs and 2 no's for Terraform. For CloudFormation we have a different picture. We have also 9 kudoses and 4 OKs. So by looking at these graphs, I would say that CloudFormation wins the battle. As you see, both tools are more or less equal in their set of features. Earlier I mentioned that I'm a big fan of Terraform, but I also met fans of CloudFormation. Honestly, still I met more people who like Terraform, but maybe my circle of communication is not that representative, I don't know. Still, my conclusion here is that these both are tools and they both serve your purpose. They both can do what you need from them. They both can solve your task, they both can solve your issue. If you want to manage not only AWS, but multitude of different providers, even for example GitHub, PagerDuty as I mentioned, maybe Google Cloud and so on, then I will still believe Terraform is a better choice, because the cloud agnosticness, it's cloud agnostic by design from the start. For CloudFormation you have support of it, but I suppose it's still in slightly raw state. If you're all in AWS, then I think the best solution is to check them both and see what fits you better, what suits you better, which syntax you prefer. Maybe you try to create a few resources using Terraform, using CloudFormation, and you see how it works. So I think this is the way we should be picking resources in nowadays world, not by just watching how a random dude on YouTube talks about these tools, but actually going there and trying them on your own, taking time to familiarize with them, and then making a proper decision, discussing with your team and so on. That's it for today. I hope I gave you enough of food for thought and your choice will be easier. Anyway, I would really appreciate your feedback by just giving me thumbs up, thumbs down, as you know, subscribing if you wish. As you see, I'm not publishing videos that often, however, now with the new camera, I will try to do so. And please leave your comments or approach me somewhere. All the best for you and stay healthy.